Right, now this is your fourth video of today, and all these questions are based on the first order reaction model questions. Okay, I have solved four model questions from the first order reaction from the chemical kinetics, and this particular question is very important for CSIR. They actually do not give you this, instead they'll give a question something where you have to use this particular kind of formula. So for various reactions like this, for unimolecular, bimolecular and so on, you'll be having a common formula in the terms of pressure, okay, in this way based on the stoichiometry is given. From that you have to solve something else. So if you know how to solve this particular procedure of how to find that particular equation, you can easily solve in the exam, right? So the question says nitrous oxide N2O decomposes into N2 and O2, the reactant and the product being all gases. If the reaction is first order, develop an expression for the rate constant as a function of time, initial pressure and the total pressure. Now, the decomposition reaction for N2O can be written as N2 plus half O2. Now what we have to do is, with a function of pressure and time, we have to write the what are the stoichiometries, right? At time t is equals to 0, what will be the pressure? Initial pressure, let us consider it as Pi, right? Now what will be the concentrations? It will be 0 and 0. Okay, I'll not put my pen, it's really blinking. Okay, at time equals to t, it is Pi minus x. Okay, now at some time t there will be some change in the initial concentration of the reactant. That change will considered as Pi minus x, right? So what will be the resultant product? Will be x and 1 by 2 x, because this is 1 and that is 1 by 2, so I'll write x and 1 by 2 x. Now, according to Dalton's law of partial pressure, the total pressure at time t is given by, we know that Dalton's law is sum of all the pressures will give you the total pressure. So the individual pressures, you just add all these three at time t, you will get Pi minus x plus x by 2. So the total pressure comes out to be Pi plus x by 2, right? From this we can find what is the x value. So what is the x value? X will be 2 into P minus Pi if you solve this particular equation. Now, what is the actual thing is, we have to find out K is equals to 1 by T ln A by A minus X, a general first order reaction. In terms of pressure, it is Pi by Pi minus X. Now we are trying to find out Pi minus X value. So how do you find it? Pressure of NO2, that is this particular thing. I have written NO2, sorry, it is N2O. Okay, this is N2O. So N2O at time t is Pi minus x. So that particular value we want. So Pi minus x is equals to Pi minus x value, just substitute over there. So you'll get here Pi minus x value. Okay, I'll just correct this now. So the first order equation can be written as K1 is equals to 1 by T ln Pi by whatever Pi minus x value you get, you just substitute in the Pi minus x place, right? So this is the way you have to solve the questions. Like, many questions do appear in the exam where this is the first procedure which you have to do, and then substitute the values which are given in the exam. So be prepared with this kind of model questions, and not much from the first order, but then I have taken few questions which you may get for the 2 marks in the CSIR, we cannot say. Okay, so in a first order reaction, it takes the reactant 40.5 minutes to be 25% decomposed. Calculate the rate constant of the reaction. Okay, what you have to find is your K value. So you have been given that 25% of the reaction or the reactant gets decomposed in some particular time. What is the time? 40 minutes, 40.5. So the remaining reactant will be how much? 75%. So we know the rate constant formula is K is equals to 1 by T ln A by A minus X. A value, if you consider as A only, what will be the change? The change in the concentration is at that particular time. If 25% is decomposed, the left out, the remaining concentration A minus X is 75%. So in the place of A minus X, you will write 0.75 A. Is it clear? So you're just replacing the 25 is decomposed, the left out you are writing in the place of A minus X, that is 0.75 A. So A gets cancelled, and if you solve the whole equation, you will get your answer, the rate constant 7.11 into 10 power minus 3 minute inverse. Right. Now this is one particular thing which you should know, a very basic thing when you talk about first order reactions, because based on this also you can expect a 2 marks question. So for a first order reaction, in a first T half, how much of the reactant is decomposed is 50%. Okay. And in another T half, 25% is left out, 75% is decomposed. And in another T half, it is 12.5, 6.25. I just have divided 100 by 2. Okay. Just divide everything by 2 to get the next term. 100 by 2, 50 by 2, 25 by 2, and so on. So you get these particular terms. So T 50% is T half. Okay. To decompose the 50% of the reactant, how many T halves are required? Only one T half. To decompose 75% of the reaction, how much we need? How many T halves are required? Two T half. So this is one T half, two T half, three T half, and so on. Now based on this, you may get a question. Okay, if T 75% is 150 minutes, calculate T 93.75%. Now how do you do that? If you know this thing, you can easily solve it. So T 75%, we know it is 2 T halves. Okay, two half lives are required to decompose this much percent of the reactant. So 2 T halves, and it is given as 150 minutes. So if 2 T halves is 150 minutes, then what is half life? T half is 75 minutes. Now T 93.75%. Okay, that is 4 T half here. If you add 4 T halves, the decomposed will be T 93.75. So T 93.75 is 4 T halves. 4 into 75 will give you 300 minutes. That's a simple way to solve this kind of questions. It's just like a revision for you. In case you get in the exam, you should be prepared with all these things. Another question, a little different from the previous one. Let's say you have been given with T10 10% as 2 minutes, and then calculate T 19%. Okay, then you take a T 10% and 19%, apply the formula 2.303 by T log A by A minus X, substitute the values. If you substitute the values, like I have written, the left out, if this is decomposed, left out will be 100 minus 10 is 90. Just a minute. Okay, it's 90, not 9, right? This is 90, and then here it is 100 minus 19 is 81, right? So 10 by 9 I have written, that is 9 square is 81, 10 square is 19. So the whole square I have written, and this can be written as uh, log a power x, or log x power a. Yeah, x power a. The constant will come to the here, right? That is log x power a is equals to a log x, right? So this will become 2 log 10 by 9. Now this things gets cancelled, and 1 by 2 is equals to 2 by t. So t comes out to be t is equals to 2 into 2, 4 minutes. This is the another way you may get in the exam, right? Now this I have just written, like in the worst case, if you get some complicated equation and they ask what kind of order it is, you should remember that. And if there is some radioactive element in it, you should know that all radioactive disintegrated reactions are first order reactions. And the most famous reaction, that is hydrolysis of ethyl acetate, it is also a first order reaction. Okay, thank you.